Unit 2B, Lesson 2, Sequences as Functions. So in this lesson, we're going to talk about sequences, arithmetic and geometric, and neither. Sequence is simply a list of numbers that follow some sort of pattern. So we're going to look at some different examples next. Two types of sequences we're going to look at are arithmetic and geometric sequences. An arithmetic sequence is a list of numbers that have a common difference. So for example, we would take a look at the sequence 8, 14, 20, 26, and then that pattern would continue on. We're trying to find out what's happening from our previous number to the current number. To go from 8 to 14, we have to add 6. 14 to 20, we add 6. 20 to 26, we add 6. So this is arithmetic because we're adding the same value each time. The common difference in this case is going to be D equals 6. D just stands for the common difference. That common difference is 6. If we were subtracting each time, that is still going to be arithmetic. It's just that our common difference would then be a negative value. The second part we want to look at is a geometric sequence, and that is a list of numbers that have a common ratio. So we're multiplying by the same value each time. So for example, we would have 3 to negative 6 to 12 to negative 24. Notice we're alternating between positive and negative numbers. So our common ratio is going to be a negative value. We have to multiply 3 by negative 2 to get to negative 6. Multiply negative 6 by negative 2 to get to positive 12. Multiply positive 12 by negative 2 to get negative 24. So we use R to represent the common ratio, and that value is negative 2 in this case. So arithmetic, we're adding the same value each time, whether that's positive or negative. Geometric, we're multiplying the same value each time. And then a sequence that does not follow either of the above patterns, so we're not adding the same value each time, or we're not multiplying by the same value each time, we simply call that neither. For the examples, we want to determine if the sequence is arithmetic, geometric, or neither. And then we want to find the common difference or common ratio if it applies to either being arithmetic or geometric. So for the first sequence, we go from 14 to 6 to negative 2 to negative 10, and then that pattern continues. So to go from 14 to 6, and then from 6 to negative 2, my values are getting smaller. We can see they're decreasing each time by negative 8. So this would be arithmetic because we're adding the same value of negative 8 each time. The common difference would be negative 8. Now to the next sequence, we go from 1 to 1 to 2 to 3, 5, 8, 13, 21, and then that pattern continues. This is actually a particular type of sequence, but it is neither arithmetic or geometric. As the pattern goes on, you can see you add the previous two terms to get the current term. So we would take 2 plus 3 to get 5, 3 plus 5 to get 8, 5 plus 8 to get 13, 18 plus 13 to get 21, and then that pattern would continue. This is called the Fibonacci sequence. It consists of the Fibonacci numbers. We'll talk about that more later on. But this, for the sake of what we're trying to solve, would be neither. We're not adding the same value or multiplying by the same value each time, so it is neither. Now to the last sequence, we go from 3/4 to 3/16 to 3/64, and then that pattern continues. I notice each time that my numerator is staying the same. It's 3. So now I just focus on the denominator. I go from 4 to 16 to 64. So to go from 4 to 16, I would have to multiply by 4. To go from 16 to 64, I would have to multiply by 4. If my numerator is staying the same, I must be multiplying that by 1. So each time I'm multiplying that fraction by 1/4 to get the same fraction, or to get the next fraction. 3/4 times 1/4 gets me 3/16. 3/16 times 1/4 gets me 3/64. So this is geometric because we're multiplying by the same value each time. Common ratio is going to be 1/4. So in this lesson, we talked about the main types of sequences: arithmetic, adding the same value each time; geometric, multiplying the same value each time. If it doesn't follow either of those two patterns, it's neither. And we also talked about the Fibonacci sequence. We'll work more with that as we go on.